Okay, welcome to the model problem 1 for two-step mole conversion problems. So the problem reads, how many grams of H2SO4 are in 1.30 liters of a 2.4 molar H2SO4 solution? So remember, our steps are to identify our given and find, map out a plan, and then solve using equations or dimensional analysis. And I will show you how to use both in this video. So let's start off with our plan and identifying our given and find. So I'm given 1.30 liters of a 2.4 molar solution. So when I see the word solution, I know I'm dealing with concentrations of solutions. So I'm over here on the mole map. And specifically, they're giving me the volume. I know it's the volume because it's liters. The units for volume are liters. And I'm given the concentration. So I'm starting here, and I'm asked to find the grams. So that would be the mass. So I'm trying to get over here form of H2SO4 in that solution. So my plan is to go from concentration and volume to moles, and then from moles to mass. So this is the plan that I have mapped out. Okay, now let's look at how we can solve this problem using equations first. Now the first equation that I want to use, if I want to go from molarity to moles, I'm going to use this equation that's on the mole map here. Molarity is equal to moles of solute over liters of solution. And so that's the equation. I sort of abbreviated it here. Now what I'm going to do is I'm going to plug in the values that I have into that equation. And remember, you always want to check that, make sure that your units are appropriate, because if they're not, then you are going to sort of struggle a bit. So with that being said, my units are great. My liters, my volume is in liters, and my molarity is molar. So I'm going to take and plug into this equation 2.4 in for my molarity, and then 1.3 for my liters. Now why don't you take a moment to do that yourself if you need to pause the video. All right, when you've done that, you should have an equation that looks like this, okay? So now the question is, well, how do we solve that? So to solve that, remember, we are going to, if you have a fraction next to an equal sign, you're going to use cross multiplication. So let me go ahead and set us up for that. So I'm going to start by putting the whole number over 1 just to make it into a fraction. And then I'm going to cross multiply. So the math I have here is that my 1 times my moles, which is just my moles, is going to be equal to 2.4 times 1.3. And that's what I have here. So moles is equal to 2.4 times 1.3, and then I multiply that out and I get 3.12 moles. Now just to make a quick note here, I have one extra significant figure because, so if you look at my math, I have 2 sig figs and I have 3. So my final answer should be in 2 sig figs. However, this is not my final answer. Remember, I still have one more step. So when you're doing math like this and you're using significant figures, it's always a good idea to have at least one extra significant figure until you get to the final answer, and then you're going to round it to the right number of sig figs. Okay, so now I have my moles. So I went from volume molarity to moles. Now I need to go to mass. All right, so for that, we're going to use this equation, moles equal to mass over molar mass. So the first thing I need to do is I need to get the molar mass for H2SO4. Now remember, we can get that from the periodic table. So I use my periodic table to calculate my molar mass. Here's my work for it. Just multiply the average atomic masses with the subscripts in the chemical formula. And I get the molar mass of H2SO4 to be 98.08 grams per mole. Now what I'm going to do is I'm going to plug in this information into the moles equals mass over molar mass equation, which is the next equation I'm going to use. So my moles, that's going to come from the previous problem. I'm going to plug that in there. And my molar mass is what I found up here. So take a moment now and plug this into the equation on your own. And if you need to, go ahead and pause the video. Okay, so when you plug that in, you should get this. 3.12 is equal to mass over 98.08. And remember, if you have a fraction next to an equal sign, you can use cross multiplication as a shortcut to solve. So I put that whole number over 1 to make it into a fraction, just to make it a little easier. And then I cross multiply. And when I do that, I'm going to get 1 times the mass, so that's just the mass, is equal to 3.12 times 98.08. So I just multiply these two numbers, and I get 306 grams. Now, this is my final answer. However, remember, we only have 2 significant figures, right? So I need to cut that off at 2 sig figs. So when I do that, I put my cutoff line here. I look to the right. I have a 6 there, so that's going to round up to a 1. So I get 310 grams, and that's my final answer. Okay, so this is the work for solving this using equations. Well, what does it look like using dimensional analysis? So dimensional analysis, we're going to have it's the same plan. We start with the volume and molarity, and then we convert it to moles, and then from moles to mass. So the same thing that we did up here for this problem. However, in dimensional analysis, the setup is typically you take your given value, put it over 1, and then use conversion factors from your mole map. However, the one thing that's sort of tricky or difficult in this problem is that our given is molarity. And molarity, the units of molarity is actually moles over liters. That's sort of a composite unit, it has more than one unit to make up the unit of molarity. So when we do our given over 1 here, we write 2.40 moles over 1 liter. That's our given over 1. And then we would multiply it by the volume, and I put that over 1 just to make the volume into a fraction, and then multiply it by the mass, the molar mass over 1 mole, and that will give me the same answer. Now, as I said before, when you have work that involves concentration equation or PV equals an RT equation, you don't typically use dimensional analysis, so you wouldn't be asked to sort of set this up. But I just wanted you to see it so you can see what this looks like. And this one's a bit tricky and it's a bit weird. So you don't have to worry about doing this or having to figure out the setup for these things when it involves molarity or PV equals an RT. But I just wanted to show you in case you were curious. All right, so that is it for this video. The next video we'll go over question 2.